Hello class, welcome to Electrical Circuits 1. This time we'll be on first order circuits. Now that we have considered the three passive elements, resistors, capacitors, and inductors individually, we are prepared to consider circuits that contain various combinations of two or three of the passive elements. In this lecture series, we shall examine two types of simple circuits. First is a circuit comprising a resistor and a capacitor. The second is a circuit comprising a resistor and an inductor. These circuits are called RC and RL circuits, respectively. We carry out the analysis of RC and RL circuits by applying Kirchhoff's laws, as we did for resistive circuits. The only difference is that applying Kirchhoff's laws to purely resistive circuits results in algebraic equations, while applying the laws to RC and RL circuits produces differential equations, which are more difficult to solve than algebraic equations. The differential equations resulting from analyzing RC and RL circuits are of the first order. Hence, these two circuits are collectively known as first order circuits. In addition, there are in addition to there being two types of first order circuits, that is the RC and the RL, there are also two ways to excite the circuits. The first way is by initial conditions of the storage elements in the circuits. In these so-called source-free circuits, we assume that energy is initially stored in the capacitive or inductive element. The energy causes current to flow in the circuit and is gradually dissipated in the resistors. Although some source-free circuits are by definition free of independent sources, they may have dependent sources. The second way of exciting first-order circuits is by independent sources. So in this lecture series, the independent sources will be that we shall consider are DC sources. So the two types of first-order circuits, that's RC and RL, and the two ways of exciting them, that is source-free, then by the second is by the independent source. So that would add up to 4 possible situations. So that's why we have these 4: source-free RC and source-free RL, step response for RC and step response for RL. In step response, we have the independent sources. Okay, so let's start with source-free RC circuit. A source-free RC circuit occurs when its DC source is suddenly disconnected. Okay. So, bale, before sa disconnect, so si capacitor nimo, it has long been connected to the source, independent source bale. Then sa to pa makuan siya, mapuno bale siya sa iyang charge. So katong pag disconnect na ay suddenly, so ma-source free na din siya. So mo nang ato ang source free circuit. So bale, the energy already stored in the capacitor is released to the resistor. Since the capacitor is initially charged, we can assume that at time t equal to 0, the initial voltage V at 0 is equal to V at 0, V sub 0, with the corresponding value of the energy stored at W sa atong capacitor at 0 equal to 1/2 C V sub 0 squared. Okay, so if we'll have sa ano to pagkuha sa ato ang voltage across ato ang capacitor kung RC source free tang RC circuit. For that, let's apply KCL at the top node. That would be IC plus IR equal to 0. IC, as we know, sa atong capacitor inductor na lecture, the current through a capacitor is C dV dt, and the current through the resistor is V over R. Now, if you rearrange that, we'll eventually arrive at this. That's dV over V equal to negative dt over RC. Then, if we'll integrate this equation, we'll have, diba, 1 over V, that's ln V, kung i-integrate na to. Tapos, then kini constant raman eh. So that's negative. Ang kung integrate nimo si dt, so that's t. So that's why we have negative t over rc plus lna. Asam ning lna gikan? lna is just the integration constant. Diba kung indefinite integral to ang gamiton, we have to introduce an integration constant. Kung definite, so matong wala na. Pero kung indefinite, we'll have an integration constant. Now, basta mangutana mo, sir, kasagaran ng integration constant kay C man. Yes, it's C. But LNA is still a constant. So, pwede gapon na nimo gamiton as an integration constant ang LNA. As long as it's a constant. Ngano LNA pod kay para eventually kung imuhaning subayon, you'll see nga na any purpose ang LNA. That is aron nga maka-arrive ta sa ingan sayon sayon ta maka-arrive sa inganing expression sa ato ang V of t. So padayon ta nata LNV, then nata LNA diri sa pikas sa isang equation. So pagbalhin ana, it's LNV minus LNA. And ang kung subtraction sa mga logarithms, di ba, it's equal to ln v over a. So natay negative t, natay negative t over rc. Then karong dumani ato raning ang both sides erase na to sa e to the this, then kinina pod, so that would be e to the ln v over a equal to e to the negative t over rc. And this one, e to the ln u, that's equal to u. And u here is v over a. So v over a equal to e to the negative t over rc. Then v is equal to a e to the negative t over rc. Now, unsa may value sa atong integration constant? As we know, kinahanglan ma-determine na nato sa atong mga boundary equations. So, for example, katong at t equal to 0, di ba? Kung t equal to 0, unsa man, naman tayo certain value. No? So, pwede nato na magamit. So, at t equal to 0, v0 is equal to a e to the negative t is 0 over rc. So, e to the 0, that's 1. Ang pasabot si a is equal to v at 0, which is also equal to v0. Ang pasabot, ang ato ang integration constant rin ang a, dili integration constant kay ln a man to. Ang pasabot, ang kining constant a is just equal to v0. Okay? In short, para sa ato ang source free ng RC circuit, ang voltage across ato ang capacitor is just equal to the initial voltage times e to the negative t over rc. And as you can see, e to the negative t over rc, di ba? This is an exponential function. Tapos negative man, nagpasabot nga, it decays through time. Magkadugay kay magkawala siya. Okay, so since di ba ang kining response sa ato ang circuit, this is due to the initial energy stored and the physical characteristics sa ato ang circuit, and it's not because this is not due to some external voltage or current source. So tungod ana, we call it the natural response of the circuit. Tapos if we'll consider this graph, kini siya kining voltage response sa source phase RC circuit. If we see at this sa graph, at t equal to 0, ang atong voltage kay atong initial voltage nato nga v at 0. Then as time increases, the voltage decreases towards 0. Now unsa ni kapaspason ang pag-decrease niya from v sub 0 padulong 0. So the rapidity with which the voltage decreases is expressed in terms of the time constant si tau. Bali, kining time constant tau, it is the time required for the response to decay to a factor of 1 over e, or that is approximately 36.8% of the initial value. So karon kanang 1 over e, bali nagpasabot na nga si tau ni mo diri si tau is equal to rc. Okay, kay ngano man Ilang taon na to, nasabay pen. Kini kano sa man ni kini nga expression kano sa man siya mahimong 1/e. Di ba? Mahimo ra na ingana kung kini siya, kini exponent na to, mahimo na siyang -1. And mahimo ra ng -1 kung ang ato ang tao, kini siya, kung ato ang tao is equal to sa man RC. Ano, mahimo ra ni siyang, sorry. Mahimo ra ni siyang -1 kung si t na to is equal to RC. Di ba? Kay ang time constant kay ang mo man na ang time nga gi-require para nga imong response bali imong response kini kay ma equal to 1/e, and mahimo ra ng 1/e kung 1/e or 36.8% sa imong initial value sa imong gisabo. So mahimo ra ng 1/e kung si t at time equal to RC ra, di ba? Itong -RC/RC, so na kay e to the -1, which is equal to 1/e. Pinapasabot nga si tau is equal to RC. So that's why we can also express it. Ang v of t na to is equal to v sub 0 e to the -t over tau. Then sunod, tanawan ni nga table. Notice that for every time interval of tau, 1 tau, 2 tau, 3 tau, 5 ka tau. So, ma-notice nimo that if you'll try to if you'll try to use your calculator, you'll notice that this one is 36.8% of this one. Kinina po siya, it's 36.8% of this one. Okay, sa to pa, as nagka-increase ang ato by a factor of tau, by a multiple of tau dahil, nagka-decrease po ang ato ang value sa ato ang v of t over v sub o by 36.8%. So, tapos kung lantaw na to, after 5 time interval, sana kini siya. 5 tau, at 5 tau, it's 0.00674, which is less than 1%. Okay, that's why it's customary to assume that the capacitor is fully discharged or fully charged after 5 time constants. Now, unsa na katas ang time constant kanang 5 time constant, it depends sa imong RC kay di ba si tau it's R equal to RC man. So for example, kung mas dako kang capacitance, di mas dako imong tau. Okay. And kung mas dako imong tau, at 5 tau, ay pa siya less than 0.1. Kumbaga, kung mas dako imong capacitance, mas dugay ka nga maka-charge, maka-fully charge or maka-fully discharge. Pero kung mas gamay pod, so mas gamay si tau, kay mas gamay man si C. So kung mas gamay mo ang capacitance, then mas dali ra pod bali mapuno or dali ra pod mahurot. So tungod kay tungod kay at 5 time constants kay almost mahurot naman siya. That's why, or almost nga puno na siya. Okay? Mao nga it's by convention, it takes 5 time constants for the circuit to reach its final state or steady state. Another thing to observe ani kay kini siya nga ay wait lang. Katong ganina. Katong regarding sa imong tao, kung mas taas mas dako imong tao, that is mas dako imong capacitance, katong ako isulti ganina, mas dugay ka maka-charge. The small kung isulti na nato in another way, the smaller the time constant, the more rapid the voltage decreases, or dugay ka maka-charge or dugay ka the more rapid nga maka-charge or the more rapid ka maka-discharge. That is, the faster the response, in short. Pero kung dako pa rin mo hang time constant, so mo to ang opposite pod. Tanawan ni siya. At 0.5 ta, paspas siya, di ba? Yang pag-discharge. At 1 tao, at 2 tao, mas dako, ay mas dugay. Okay. Sa to pa, ang rapidity kay nagdepende sa imuhang time constant. But of course, at any rate, whether the time constant is small or large, the circuit reaches a steady state in 5 time constants. Darita? Since na solve naman nato si voltage sa atong across atong capacitor for a source free RC circuit, ato na pong isolve si current. Ang current nato, that's just ang current through our resistor. It's just equal to ang atong voltage across atong resistor divided by R. So that's V sub O over R, e to the negative T over tau. Then ang power nga gidissipate, kaya diba nag-store man siya energy. Ang katong nga energy, once nga source free na siya, katong energy i-consume ra pud din to sa imong resistor. Now, pila man ang power it's VI squared. So that's substitute lang ka. So that would be V sub 0 squared over R e to the negative 2t over tau. Then ang energy adto mo to sa ang isulti ganina, di ba, at initial condition kini time equal to 0, ang katong initial nga energy nga na kay capacitor, it's 1/2 C. Sorry, it should be VO squared. Should be VO squared. Okay, this is 1/2 VO squared. So, kung integrate na nato si power, so PR dt, substitute lang, then we'll arrive at this one. That is 1/2 C VO squared 1 minus e to the negative 2t over tau. Then as you can notice, kung at t equal to 0, so 1 na siya. Tapos t at kung dugay na bali for a long period of time ba. So di ba kung ang t na to dra may increase, so mo 0 ni siya nga part. Ang pasabot nga as time increases, mahutdon ni resistor o consume ang energy nga na-store kay capacitor. Okay, so in summary, para sa ato ang source-free RC circuit, remember this, the key to working with a source-free RC circuit is, una, pangitaon sa ninyo ang V sub 0. That V at time equal to 0, that's equal to V sub 0 across your capacitor. Kaduha, inyong pangitaon kay ang time constant tau. Tingnan naman, tanawa. V of Vt is just equal to V0 na may tau. So, substitute na din naman dito. Makuha na din ninyo. Diba? Tapos kung makuha na ninyo si V, then ang other circuit variable, si I, sa imong resistor, si imong power nga dissipate sa imong resistor, ang energy nga na-consume sa imong resistor, makuha na din na nimo. Musunod na din na sa. Tapos ani daay, kung ang imong circuit na siya isa ka resistor, pag man naidaghan kay daghan capacitor, complicated nga mga resistors, isa capacitor then complicated nga connection sa imong resistors. Mas inga na simplify sa daan ko asa ang Thevenin equivalent sa imong resistance, kung R equivalent or RTH nimo. Kay taasa na dayon I had nimo i-imagine bali as equivalent nga ingani bali nga circuit. That's isa ka capacitor din isang ka resistor. Okay. Para bali para ma-simplify imong pag-analyze, or kung imong pong capacitor ani kay daghan complicated katong sa ato ang series parallel nga capacitor, pwede pod to combine nimo. Okay, aron nga maingani siya. Let's have an example. The switch in the circuit has been closed for a long time and is open at t equal to 0. Find the voltage across atong capacitor for t equal to 0 and t greater than 0. Calculate the initial energy stored in the capacitor. So, ningon siya, find find the voltage at t greater than or equal to 0. So, pangitawan sa nina to. Si V at 0. Okay. So, at timeless, di ba? Ang sa katong sa ganina, ang V at 0, alam mo sa katong property sa atong capacitor. Ang property sa capacitor kay sinidili siya mo abruptly change yung iyahang voltage. Okay. Sa to pa, ang voltage sa imong capacitor at time equal to 0, exactly equal to 0. That's also equal to the voltage at time just immediately before 0. As we progress atong lecture, that's denoted as 0 minus. Tapos ang katong time immediately after time equal to 0, that's 0 plus. Okay. So mao nang bali at 0 minus, so that's at least less than 0. Katong immediately before yun sa t equal to 0. Naman to a certain voltage, di ba? Atong na-store nga voltage. So pwede dito ata magkuha. So bali kung imong pangitaan kay V at 0, imong i-consider na nga kay at time less than 0. Now, at time less than 0, unsa man kung lang taon nimo ning kini siya nga direction, iba ning open siya at time equal to 0. Nagpasabot before 0, time less than 0, na close ning switch nimo. So kung close ang switch, yun siya, it has been closed for a long time. Nagpasabot, naka-steady state na ni siya. So kung naka-steady state na unsa ito, basta at DC voltage ng ato ang capacitor kay open. Diba kay I is equal to C dV dt. So kung si dV dt kay 0, then I is equal to 0. That means open siya. So kung open siya, then ang ato ang voltage across sa ato ang capacitor, kung magkakini siya, diri man is capacitor, di ba? Mo ni. Voltage ani across sa imong capacitor is just kini. Voltage sa imong across sa imong 9 ohm nga resistor. Kini wala nilabot kay wala man kay current kini agi diri. Di ba? Kay ang current nga moagi sa imong capacitor kung DC ka, 0 man. Okay. Sa to pa ang voltage nimo across ani is just kini ang basihan across sa imong 9 ohms. So and as you can see, kanang 3 og 9, then natay voltage source, independent voltage source dire, that's a simple voltage division. So 9 over 9 plus 3 times ato ang source, so we have 15. Therefore, kining 15 volts mao ni ang katong voltage bali initial voltage ni capacitor just before ning open ang ato ang switch. 15 volts iyahang voltage ni capacitor. Okay, so mo ni V at 0 is just equal to V sa imong capacitor at 0 minus, that's just immediately before 0, and that's equal to 15 volts. Ngano ganina nakabase na sa katong property sa capacitor nga dili abrupt nga mo change ang iyahang voltage. So kaya na naman tayo V at 0, di ba kanundon mo ganina nga slide, the key to working in source-free RC circuits is by finding V at 0 og ang tau. So nanatay V at 0 karon sa tau na punta. In finding tau, ang ato ang di ba tau is equal to RC. Ang ato i-consider ana kay ang ato ang circuit at time greater than 0. Ato nang butang. Namdumiha kung ang tau you have to consider a time greater than 0. Kung V0, imo i-consider ana a time less than 0. Bali, imo ang configuration sa imong circuit at time less than 0. And kung tao na pod, ang configuration sa imong circuit at time greater than 0. So greater than 0, di ba? Pag 0 gid ani, naingani na dahil siya. So mo na ni. So at greater than 0, ingani na pod siya, no? Ingani gapon siya. And sa ingani nga configuration sa inyong mabantayan, this is now a source-free RC circuit. No? So padayta. So kay unsa man karon, unsa naman pod ang ato ang sa matong tao ani. Inumdumi nga ang kini nga R, this is the kini siya nga R. This is the resistance seen sa terminal sa imong capacitor. That means as seen as viewed gikan sa terminal sa imong capacitor, kini silang duha kay naka-series. So that's why R na to ani will be 1 plus 9. Then C, that's 20 millifarad. So 20 times 10 to the negative 3. Then tau na to is equal to 0.2 seconds. So nanatay V at 0, nanatay tau. So substitute lang ka. Ang imuhang ang expression or imong voltage across imong capacitor for time greater than or equal to 0, that's 15 e to the negative t of ang taon nimo kay 0.2, or that's simplify na to 15 e to the negative 5t volts. Tapos ang ingon sa ipa-appeal man ang initial energy stored in the capacitor. Diba kanundam mo ang initial energy nga na-store sa mga capacitor kay diba gi-charge mo daan to 15 volts. Ang initial energy nga na-store ana, it's 1/2 C V squared, V sub 0 squared. So that would be 1/2 C is 20 times 10 to the negative 3, V sub O is 15 squared. So we have 2.25 joules. Karon para sa source-free RL circuit, basically ano ra kining same idea ra gihapon sa ato ang RC circuit, same idea ra na ang gibuhat mao nga ang form ana pare-pareho ra pod. Okay, so you can just follow through this. Tapos para sa RL circuit, inyong pangitaon lang kay si I sub 0. Ganina sa RL source free RC kay V sub 0. Karon para kay source free RL si I sub 0 inyong pangitaon, then the same tau. Galing lang ang tau diri is R over L. Okay, but still ang process pare-pareho rin yapon. So ang pag-analyze po ninyo sa circuit, pare-pareho rin yapon atong ganina. Okay, so dito madugay anita sa unit step function na wait lang. Ano ra? Sorry, diri ata sa unit step function. Help us make sense sa response atong first order circuits to a sudden application sa of independent DC voltage or current source. Kinahanglan nato ni consider kining singularity functions. Morning akong gi-insert na siya. Okay, so there are primarily tulo ka buok singularity functions, usual, pero ang mas magamit nato kay kini as of the moment kining unit step function. Wait lang, this is unit impulse, sorry, nabantayan. So this is unit impulse. Okay, una direta sa unit step function. Unit step function, kumbaga 1 at t greater than 0, at t less than 0, kay 0 ay mga value. Okay, at t exactly equal to 0, undefined na siya. Okay, tapos pero kung ano siya, ano kaya sa to 0 then 1, so bali ana ra imuhang mga values, then at time equal to 0 para ani undefined. Butang na lang din yun dira, undefined at t equal to 0 dugang and at t equal to 0. Karon diri na pud ta sa unit impulse function. Ang unit impulse function kay aside from t equal to 0, 0 na siya ihang palitanan. Aside from that, diri ang katong yung at time equal to 0 undefined siya. Now, this is physically impossible actually. Pero paano siya? Useful ni siya mathematically sa pag-analyze nato sa mga circuits. And pwede niyo una-una ni as kuan kaning grabe ra gid ka, perting gamayang width that mura siya ma-integrate niyo from 0 minus to 0 plus. Okay, mura immediately before 0 or immediately after 0. So kung i-integrate nimo, you'll have 1. So mo nang gitawag siya nga unit impulse function. Then tomato no unit impulse function is 0 everywhere except at t equal to 0 where it is undefined. Then ang ramp function, it is 0 for negative values, that is at t less than or equal to 0. Then mag-increase din siya. That is for t greater than or equal to 0, our ramp function is equal to t. Okay. Pero again, ang ato ang gamiton usually ani kay ang unit step function. So may atong i-discuss. The unit step function is 0 for negative values sa imong t and 1 for positive values sa imong t. The unit step function, again, it's undefined at t equal to 0, where anang sa time equal to 0, abrupt yung pag-change from 0 to 1. Tapos, ang kining unit step function, anong important niya siya because we can use this to represent an abrupt change sa ato ang voltage or current. Just like when we switch on our lights in the house, o sa mga switch ta, pwede na nato ma-express ma-represent mathematically using our unit step function. So for example, this one, kung ato ang, di ba, Vt at less than 0, 0 siya. Pero at time greater than 0, nakay V sub O. Ito pa, or kini siya, mga man at time equal to 0, less than 0, now makay voltage across A ug B, di ba? Short-circuited man na. Pero at time greater than 0, kay connect naman ni siya, ning move naman ni siya at time equal to 0. So pag connect niya dira, so na kay P sub 0 na yun. Now, ang kini dayon, to express that in a concise form, pwede ka ani V sub 0 U UT. Kaya nga naman, kini si UT at time equal to 0, na 0 man, at time less than 0, 0 man na siya. So V sub 0 times 0, so 0. So mo ni siya. Makuha ni niya. Pero at time greater than 0, this is 1. So mo ni makuha niya po niya. So bali, mas concise ni siya nga pag-represent ani. And it can be represent, kini siya na-represent mo sa ani. Diba? And kini po siya, muna yung gigamit. So bali, kini nga circuit nimo, pwede nimo ma-simplify pa yun as this kind of circuit. Okay. And same hapon sa ato ang kung current pod, for example, ani, at time less than 0, so maki-current kaning agidra. Pero at time greater than 0, ning connect na ka, kung kini siyang switch niya, kung connect na sa A, so ano din kay current. So that's I sub 0 UT. Dito sa step response sa imong RC circuit. In connection ni sa katong ganina, unit step function. Again, nganong nata unit step function, aron nga mas masabtan nato ang katna bitang during sa switching, kanang mag-switch ta. Kay na may sudden application, bali. So bali morabag 0, then na sudden application, pag switch on, na sudden application of DC voltage or DC source. So mo tong natay paraan na natay unit step function pang represent. So to start with step response sa atong RC circuit, when the DC source sa atong RC circuit is suddenly applied. the voltage or current source can be modeled as a step function, and the response is known as a step response. In other words, the step response is the response of the circuit due to a sudden application of a DC voltage or current source. So, paano at time equal to 0, mo-connect siya. So, na ay sudden application of sa independent na voltage diri sa ato ang capacitor. So, pag at time equal to 0, mainganin na lang siya, di ba? Okay, so for that, kung ato ang capacitor is initially charged, then VT is equal to V sub 0. Okay, at time less than 0. Then, at time greater than 0, ingani pa yung expression. Vs plus V sub 0 minus Vs e to the negative T over tau. Pero kung uncharged siya, then iset ra na nimong V sub 0 equal to 0. So, substitute lang kag 0 dira, eventually you'll have this one. Kining expression. So, kanang duha, 0 at less than 0, then I value at time greater than 0. So, magamitan na nimo og unit step function. Diba? Then, kung nanakaingani, VT, voltage across sa imong capacitor, ang current pod through your capacitor, di ba? Kalunda mo, ang current voltage relationship sa ato ang capacitor is I is equal to C dV dt. So, derivative lang na nimo, differentiate nimo si kining expression sa mga V with respect to time, then you'll have this one. Ps over R e to the negative T over tau U of T. Where your tau is equal to RC. Then, direta, ganina step response karon complete response yung RC circuit. Ang complete response, actually, kay kini siya. Katong sa at time greater than 0 sa yung circuit. Okay, then, kining complete response, it can be viewed in two angles. But first, ang kining complete response. Okay, it can be complete response is equal to natural response plus forced response. Again, ang natural response katong sa atong discuss ganina is the response of the circuit without the external force. Mga due to the energy nga na-store initially dito sa imong circuit. The forced response is the response of the circuit because of the external force. So natural response, it's not because of the external force or response without the external force. Ang forced response is the response because of the external force. The natural response eventually dies out along with the transient components in among forced response, leaving only the steady state components in among forced response. So that's the complete response in terms of source sa ato ang responses. Pero if we'll look at the complete response in terms of the permanency sa responses, ganina ang source, karon ang permanency. Then, express po sa complete response as transient response plus steady state response. Bale, si transient response, that's the temporary response. It is the portion of the complete response that decays to 0 as time approaches infinity. The steady state response is the portion of the complete response that remains after the transient response has died out. Now, this refers to the behavior of the circuit a long time after an external excitation is applied. Now, pangutana, how do we find the complete response? Now, whichever way you look at it, with a view ba sa source response or with a view sa permanency sa imong responses, ang complete response can be written in this form. So, kini na lang yung hinumduman para dali ra. That is, ang complete response is equal to mount voltage at saka itong dugay na kay nga time, V infinity, then inyong voltage at 0, then ang tau. So, bale, ang kanang V infinity, mo ni ang katong steady state pala nimo nga value or finite nga value. So, actually, sige lang, may example ta para eventually ma-realize ninyo nga sa'yo rin siya. Okay, so in summary, to find the step response, including the complete response, di ba si complete response kato man ang at time equal to 0, greater than 0. Si step response katong time less than 0 o time greater than 0. Ang response pa rin yung to. Okay, so basically we need three things para ma-compute na to si step response o including na si complete response. First, we need the capacitor voltage at time equal to 0. Then we need the final capacitor voltage and the time constant tau. And always bear this in mind, nga we get V at 0 at time equal to 0 sa ato ang circuit configuration nga time less than 0. Then we get both V at infinity o ang ato ang tau at time greater than 0. Tapos kini siya nga technique kanang anang dimension nako is that's equally applicable pod sa RL circuits. Okay, direta. Example. The switch has been closed for a long time, is open at t equal to 0. Find I and V for all time. So, ang V na to, it's the capacitor voltage. I na to, kay ang current gikan sa ato ang source. Duha man na itong may taon. Asa man na itong unahon aning pangita? Okay, so resistor current I can be discontinuous, di ba? Kay katong at time nga ning ning putol, ma-change naman imong current adto. It can be discontinuous. Pero ang imong capacitor voltage, it's continuous kay balag atong at time nga ning open siya na maka-initial nga nga voltage nga na store daan. So kumbaga narang gyapon kay value. Okay. So kumbaga continuous yung mga voltage sa mga capacitor. Mao nga it's always better to find V than obtain I from V. Another thing is that we are asked for the current and the voltage for all time. So for all time man kumbaga at t less than 0 and t greater than 0 sabot step response ato ang kinahanglan. Okay, let's consider ang ato ang circuit at time less than 0 para makuha nato tong V at 0. So at time less than 0, di ba ingani man, at time less than 0, that is kini. Then tanawa, ang ato kini siyang voltage, it's a unit step man nga voltage. Napasabot at time less than 0, ut is 0. So kini siya kay 0. So kung 0 na, this is just a short circuit. So mo na lang short circuit rag rin. And nabili na to, may 20. Then it has been closed for a long time man. Pasabot kini na fully charged na siya. Okay? Niya diba sa ganina ang mo kung wala na nag-change ang ato ang kung wala na nag-change ang ato ang voltage, then ang ato ang capacitor kay open circuit siya. So morning na open na siya. Okay, then napabilin si 10 volts. So as you can see, the voltage across here, that is the moment across sa ato ang capacitor at time equal to 0. So that's just equal to kining atbang niya nga voltage source. That's 10 volts. And ang current nga gikan diri sama na siya. It's just mo po nga current pag gihapon nga negative V I is equal to negative V over 10. Nato pa si I na to, it's equal to negative 1. Katawa, parallel naman na sagod. Tama, tini di ba? Nagsugod lang sa diri. Okay. So mo nang I na to. Okay, mura balik siya ingani ba? Then padulong dito. Diba? So mao nga ato ang V kay ngani. Ang I nato is equal to negative V over 10. Okay. So that's why natay negative 1. Then, so ano V0 is just equal to V at 0 minus. So that's equal to 10 volts. So nakita na nato, no? Tapos ato ang iPod. At less than 0 natin negative 1. Dayon, dali na po da. Pakitaan na to si V at a very long time or at infinity. So paraan na nawa kini naman siya pag open ana niya, pag open niya maingani naman siya, no? Ma-disconnect si 10 volts. Ito pa mabilin kini. Then kini at time ko to 0, at time greater than 0, di ba? Naman siya si 30 volts. Ito pa ingani na din ka. So at time greater than 0 kini na. Pero at time equal to very big na number na, kumbaga at infinity, yung capacitor kay ma-open naman po ni. So maingani na po din isa. Ito pa ang voltage sa itong capacitor at infinity, that's equal to voltage division ra kaani. Kay ang equal raman siya sa voltage across sa imong 20 ohm nga capacitor. So 20 over 20 plus 10 times 30. So we have pila man 20 times 30, that's 600 divided by 30. So natay 20. So V at imuhang V infinity nimo will be equal to 20. Then, so nanatay V0, nanatay V at infinity, atong kinalan na pod kay ang tau. Still, ang atong i-consider nga circuit katong at time greater than 0. Okay, so kung malantawon ninyo, across ato ang capacitor, ang, di ba, mag 7 kani. Okay, so across ato ang capacitor, tapos kung mag 7, di ba, we kill the independent sources. So across sa ato ang terminal sa atong capacitor, ang ato makita kay si 10 ohms o si 20 ohms nga nagparallel. So that would be 20 over 3. Hence, our tau is 20 over 3 times C is 1/4. So natay 5 over 3 seconds. Now, our complete response para sa atong V kay kini. V infinity plus V at 0 minus V at infinity, then e to the negative t over tau. Substitute lang, so we'll have this one. Complete response ato ang I. Di ba kini si I? That is just 10 V over 20 ang ato ang voltage dere. Okay. Voltage na to kay kini man ikaw sa ato ang voltage sa atong capacitor over 20. Tapos plus C dV dt. Okay. Mura man kabalik ani na KCL ka. Bali ang kini siya is equal to the sum of this kayong duha. And ang kini siya, that's equal to V over 20. Yan, dere. That's just the current kani agi sa imong capacitor, and that's C dV dt. So V over 20, so that's V is 20 minus 10 e to the negative 0.60 divided by 20 plus 1/4 times derivative at ani niya. So we'll eventually have this one. I equal to 1 plus e to the negative 0.60. Then, for all time ang ipangita. So, for all, ang ato ang V for all time, that would be ang atong V at 0 o ang ato ang atong ganina na na-solve. Okay, so muna ato ang unit step response. Then, ato ang I for all time, ganina at t less than 0, muna ato na-solve, negative 1. Then katong just we na-solve na to sa last slide mo ni siya. So if we are to check our answers, pwede ani, at time greater than 0, kini man ang ato ang circuit, diba? And as you can see, si 10I plus V is equal to 30 volts, no? So, pwede na ninyo gamiton, kini siya equation para pang-check sa inyong mga answers. At time equal to 1 second. Okay, so dapat, kini siya, mao ni si V plus 10I. Okay, dapat may equal to 30. And if you'll input that sa inyong calculator, that's equal to 30. Or, tisingan na ninyo ani. Di ba, ang iyahang time constant kay 5/3 man, that is 1.66 seconds. So, kini, katong less than sa, wala pa siya ni, ambot og 1 time constant. Kini, 5/3 man to, no? So, times 5, that's 15 over 3. 15/3, that's less than, ano ba? 25 dahil. 5/3 is 25/3. So, 25/3. 25/3, that is, ano naman, 8 point something. So, tingnan nato lang at 7, still 30 hapon na siya. Okay. Even if you'll try that at other time. Okay. So, dito sa step response sa ato ang RL circuit. Para sa step response sa RL circuit, same ra gihapon nga idea sa katong step response sa ato ang RC circuit. Kumbaga, at time na 0 na kay itong initial charge, initial current bali na nasa imuhang inductor. Then at time greater than 0, kini na po. Dayon, pero kung uncharged bali, kumbaga walay initial current, so 0 lang na. And we'll have this kini nga expression. Dayon, and kini, of course, that can be represented by sa ato ang by using ato ang unit step function. Then ang voltage across ato ang inductor, di ba sa ato ang voltage current relationship sa inductor, V is just equal to L di dt. So i-differentiate ang nimo imuhang I with respect to t, then multiply by L, so you'll arrive at this one. Then take note nga si tau is equal to L over R para sa atong RL circuit. Then para sa complete response, again, morning kini siya, initially charged, initially uncharged, ora ni, kini o kini. Kaya mana atong complete response. Dayon, aron mapasayon ta og kuhaan na sa atong complete response, kini ra ato ang gamiton. Para gapon sa RC circuit. Ganina VT, V at infinity plus V at 0 minus V at infinity and e to the negative t over tau. Nga na po gihapon sa atong RL, IT is equal to I at infinity plus I at 0 minus I at infinity, then whole quantity e to the negative t over tau. Ganing lang ato ang tau dito will be L over R instead of R times C. Okay, that's it for the first order circuits. Thank you.